Okay, grade 12, I just wanted you to see what I had lined up to do this experiment before I started making my mess. So what our end goal is to find out what the concentration of ammonia is in this household bottle of ammonia that can be purchased at Superstore, etc. So we're trying to figure out how much NH3 is in that bottle per serving, if you will, or aliquot, okay? And in order to do that, we're going to do a titration twice. So there's my burette right here. Okay, that's my burette. There's my burette clamp, okay? And this is what we call the stopcock. Right now, when it's horizontal, it's closed. And when I turn it up and down, it's open. Now nothing's coming out, even though it appears there's a little bit of water there, simply because the manufacturers of the burette take into account that there'll be a little bit left over. If I move in even closer, hopefully, my camera skills aren't the greatest, but hopefully you'll see the graduations actually stop well before that low water level. Okay, so the end is 50. Remember how I told you earlier in this lesson that the burette starts at 0. So I'm trying to zoom into 0 up here. Anyway, you get my point. So in order to figure out the concentration in the ammonia bottle, we will do a titration twice. So here's the first titration. We're going to take sodium carbonate, and it's what we call a primary standard, and I'll explain that later. So a primary standard, and we're going to use that to determine the concentration of our hydrochloric acid solution. So clearly this is concentrated. I'm going to dilute it down. I'm going to make a hydrochloric acid solution, and I'm going to make a sodium carbonate solution. And I'm going to titrate those together, mix them together in a titration, and determine the exact concentration of HCl. So even though I'm making it up, I may make a mistake. It may not be exactly the concentration I make up. So I'm using this first titration to determine this exact concentration. Once I know the exact concentration of HCl, I can do a titration of HCl with the ammonia solution and figure out the concentration of the ammonia. Now, back to the topic of primary standard. Sodium carbonate is what we call a primary standard. And in your notes, I will explain what is meant by a primary standard. But to give you a little sneak peek, it means that it is a substance with a very high molar mass. Its molar mass is 152 grams in every mole. Whereas, for example, hydrochloric acid is only 36 grams per mole. So this is a much larger molar mass. So if I make a little teeny tiny mistake in the mass, it's not going to make a big difference when compared to the similar mistake with hydrochloric acid. I usually talk about Santa Claus and a baby, and I'll talk about that later to compare the two, okay? Sodium carbonate is also not very reactive. So I don't have to worry about it being in storage and reacting with something else, unlike something like hydrochloric acid. Another reason sodium carbonate is very good as a primary standard is because it doesn't absorb water from the air, and other solutions and standards would. So a primary standard is something that you can make a solution of, and you know it's not going to react with anything else. You know it has a high molar mass, so if your molar mass is a little bit off, it's not going to make a big deal, and it's also not going to absorb moisture from the air. And so those are three things that make it a very good primary standard. I'm going to use that primary standard to determine the concentration of the hydrochloric acid solution that I'm going to make up. That's what we will call a secondary standard. So a standard is a solution that you know the exact concentration of. So the primary standard, I will make up the solution as precisely as I can, and then titrate it with hydrochloric acid to figure out the concentration of the hydrochloric acid. And to do that titration, I will put the sodium carbonate solution under here, and I will gradually add hydrochloric acid to it. And when the indicator that we're using, the methyl orange indicator, changes color, I'll know I have the exact same amount of moles of my sodium carbonate in here as I do of my hydrochloric acid coming down to meet it. So that's a 5-minute intro. Now I'm going to get my solutions ready. Okay, I just wanted to remind you how to make up a solution. You would have done this at the very, very tail end of your grade 11 chemistry course. So I have the sodium carbonate. I had determined we needed 1.52 grams, and that's what I have in here in the balance. So that's tared in a weighing boat with 1.52 grams. Now, I'm going to add that to my beaker. Here's my beaker at home. And to that, I am adding 50 mils of water, distilled water. Because, and I'm using my graduated cylinder, and I'm going to add that 1.52 grams of sodium carbonate to 50 mils of water. The reason I've chosen 50 mils, remember, is because I want a 100 mil solution. There's my 100 mil volumetric flask. Remember what a volumetric flask looks like? So I'm going to take half of the desired volume, and that's what I'm adding to my beaker. I'm going to add my sodium carbonate to it, stir it until it dissolves, and then I'm going to use my funnel, and I'm going to place that into my volumetric flask using the funnel, and remember a stirring rod to channel it. And then I'm going to rinse my beaker 3 times with distilled water and put those washings into the volumetric flask. That will bring the volumetric flask volume a little bit more than halfway. Then I'll add distilled water until it's about 1 finger width below that graduated line. Then I will remove the funnel. I will use paper towel, dry the neck of the volumetric, and then I will use my dropper pipette and add water until the water level, the meniscus, is even with that graduated line. And then I will stopper the volumetric flask with my stopper and invert it 30 times. Okay? So again, mass of the compound required, add it to half of the volume of water, stir until it dissolves. If it does not dissolve adequately for me, I have my hot plate ready to add heat. Stir it until it dissolves, then using the funnel, add it to the volumetric by channeling it with the stirring rod, then rinse the beaker 3 times with distilled water, putting all of the washings into the volumetric. Then add distilled water until it's 1 finger width below the line. Remove the funnel, dry the neck of the volumetric, and using the dropper pipette, add water until the meniscus, the water level, is even with that graduated line. Then stopper it and invert it 30 times.
Yeah, go ahead.
Okay, grade 12, so here's the next step. I have my 3 Erlenmeyers ready for my 3 titrations and of my sodium carbonate and my HCl. So there are my 2 solutions ready. So what you might not have used yet, I mean you should have used it in the tail end of grade 11, but I know myself, I always run out of time with my darling grade 11 students. So this is what we call a pipette. It's a graduated pipette. It's exactly 10 mils. And this is what we call a pipette pump. So what I've done, I've just poured some sodium carbonate into my beaker. I'm going to attach my pipette pump, and I want an exact 10 mil sample. So I'm moving the dial until it goes up well above the 0. And then I'm taking off the pump, I'm covering it with my thumb, and I'm going to release it until the meniscus is even with the 0. And this is the challenging part. So it's almost to the 0. There. So now I'm going to touch the side of the pipette to the beaker, and I'm going to move my pipette to the Erlenmeyer. Then I will lift my thumb and let it drain, and that will be an exact 10 ml sample of sodium carbonate. Now I'm going to do that 3 times, but I'm not going to show you all 3 times because that's just plain boring. So let it drain, and when you think it's down to the last drop, you'll touch it on the side, and it will release 1 drop, and you'll still see another drop. But you don't have to worry about it because the manufacturer has taken that into account. So I'm just going to touch it on the side of the Erlenmeyer. It releases the final drop. It looks like there's 1 more, but that's okay. That's exactly 10 mils. Now I'm going to add 2 drops of my methyl orange indicator. 1, 2. Now that is sample 1 ready. Now when you look on your pH indicator table, you will see it should be yellow, progressing to red. Okay, so what we're going to do is we're going to add HCl until it gets to yellow, and then we will continue on with our titration until it gets to red. That will make more sense. So I'm going to put 10 mils into this Erlenmeyer, 10 mils of sodium carbonate into this Erlenmeyer, 2 mils of methyl orange, 2 drops of methyl orange. Those 3 trials will then be ready. Okay, those are my aliquots, my 10 mil aliquots. Now, I'll leave and do those, and I'll come back, but in the meantime, this is your HCl. I'm going to pour a little bit of my HCl into my beaker, just a little bit. And then I'm coming over to my burette, and I'm going to add that HCl. Now this burette, I have already put distilled water through it. I've put distilled water through it, and I've drained it to clean it. Now I'm putting some HCl, some of my titrant in it. And be very careful when you do this because I'm dripping some now, which is not good. But I'm not using a beaker, as you can tell. I'm using a dessert dish from Costco. But anyway, when you put this in, be very careful because the funnel fills very quickly, much faster than you would think. So I'm adding HCl, and then I'm going to take my burette off, and I'm going to go over to my sink, and I'm going to twirl it over my sink so that I'm completely coating the inside of my burette so that all the distilled water is out. Now think for a second, why would Mrs. Tate be making sure that the entire inside was covered with HCl as opposed to water? How would that affect my titration? Now pause the video and think about that, and I'll come back. Okay, grade 12, I just wanted to show you what it would look like to take your initial reading. Remember how last week I told you you didn't have to fill it all the way up to the top, all the way up to the 0, 0. You could just start anywhere below the 0. So if you were looking at the burette and trying to read this number, it's very, very difficult. So what they taught us in university was to take an index card and just put a piece of electrical tape on it, okay? And then hold that index card with the electrical tape behind the burette. It makes it a lot easier to read the markings, okay? So I just put that behind the burette, and then I try to focus in as best as I can and read that. So it's between the 3 and the 4. I would say it's not quite halfway. So I would say that that's probably, whoops, my camera, probably, let's say, 3.48, let's say. Now I'm going to give you lots of practice in your notes in the PDF and the smartboard on how to read the burette. I'm not going to show you here with this video. It will be too challenging for me and boring for you. But that is our initial volume. So initially the reading is, let's say, 3.48. And now what we're going to do is we're going to add the hydrochloric acid, which is the titrant, which is in the burette, and we're going to add it slowly to our sample, which is our sodium carbonate in the Erlenmeyer. And we have the indicator methyl orange to help us. So I'm going to move the burette so it's a little bit lower down. I'm going to put it like so. So it's in the Erlenmeyer, so when it drops, it doesn't splash. And I'm going to slowly add it. Now, the first titration of 3, you can go relatively slow because you don't want to miss the endpoint. But after you do the first one, you'll have an idea of when the endpoint is going to happen, so you can go a little bit faster. Now, I'm going to ask somebody else in my home to videotape for me because I want you to see the proper way to hold your hands as you're titrating, because you need to have control not only of the Erlenmeyer, the solution, but also of the burette and the stopcock, because you want to continually be swirling the solution, because just one drop could make a huge difference in whether or not you reach that endpoint or you go too far. Okay? Okay, grade 12, I wanted to show you a couple of things. First of all, you can see how I put a piece of paper towel under the Erlenmeyer. Remember I told you it's easiest to see the color change when you had something white. So that's one thing I wanted to show you. Another thing I wanted to show you, sometimes in the tip of the burette, you will get an air bubble. Make sure there's no air bubbles, because that air bubble will add volume to the amount of HCl that you've added, and so it will lead to erroneous calculations of the concentration, okay? So make sure there's no air bubble. If there is indeed an air bubble, what you have to do is you have to open the stopcock and let it drain, or sometimes what you can do too is just tap it lightly by snapping your finger like that against the tip, and then the air bubble will release. But keep in mind, if you're doing that, to remove your sample from underneath, and once the air bubble is gone, to measure the top of your burette again, so you know the starting point of your volume, okay? Also, did you think as to why I had to coat the inside of the burette with HCl? I'm hoping you said because you wanted all excess distilled water out, because if there was any excess distilled water, what you're doing is you're diluting your HCl, and so its concentration will be off. Okay, so 2 things to keep in mind. Number 1, make sure there's no air bubble in the tip, and number 2, make sure that you rinse the burette thoroughly with your titrant so that it's not being diluted by any water. Okay, now what I was trying to do, and it was very, very difficult for my camera person to help me, because I wanted to show how you properly wrap your hand around the burette when you're using it. So you're going to control the stopcock with your left hand. So I have my thumb in the front and my 2 fingers wrapped around the stopcock, all right? And that's so that I can add the solution gradually while my right hand is twirling or swirling the solution in the Erlenmeyer, okay? So I'm going to try and do both, as well as operate the camera, because if I had a camera person, then you couldn't properly see my hands, all right? So I will try and do my best. Now, what I've done so far, I've added about 6 mils of HCl just to bring it to the initial base color. So methyl orange is yellow when it's in a base. So I've added enough just to bring it to the base color. Now, I want you to look carefully at the bottom of the Erlenmeyer, because you'll see as I add the HCl, when it hits the Erlenmeyer, and I'll just add a drop right now to show you, when it hits the solution, it turns pink. Okay? And then I swirl and it dissipates. So I'm just slowly opening the stopcock now to add just a drop. Waiting for that drop to come out. There you go, there's a drop, okay? And you can see how it's turning pink. But I haven't reached the end point, because as I swirl, it's dissipating. Okay, so I'm getting close though. So it's only coming out drop by drop. I'm swirling each time. I'm gonna actually try to slow it down a little bit. So I close the stopcock just a little bit. There we go. And I have my thumb and fingers on the Erlenmeyer at the neck, twirling or swirling it. Okay, I think I have it close too much. There we go. Okay. So it's coming out drop by drop, and you can see as it hits, it's turning pink. And once that pink color stays, even when I swirl, I know I've reached the end point. So remember, the end point is when there's an obvious change in color and or pH, and the equivalence point is the volume at which I've added the HCl to create that end point. So I'm getting closer, that pink is staying longer. So I'm going to do this 3 times with my 3 different trials, and then I'm going to do the same thing but with ammonia and HCl. So you can see it's getting harder and harder to get rid of that pink. I have to swirl longer. Now, as you get close, I would advise, so we're pretty close right now, I would advise that if you were in the lab, that you take the reading of the burette where it is right now. This is where it's fun trying to use the camera and line things up too. So I would take that volume and record it so that if you did actually go too far, then at least you have a recording to back up on, okay? So we started, I think we said something like 3.49 or something, and now we're down to about, it's very difficult to see on the iPad. I'll have to look closer and record it. Anyway, 12 something. Okay, see if I can get this back to where we were. I think I should be getting A++ on all my camera skills during this COVID thing. Learned a lot, grade 12, I'm not gonna lie. All right, let's see. Okay, opening the stopcock just a little bit, trying to let you see the HCl hit the sample of sodium carbonate. There we go. Okay, so now I have that reddish color. Okay, I think that's very, very close to the end point, if not the end point. So I would record the volume that's on the burette now, and then I would add another drop or 2 or 3 or 10 and see if the color changes. And if it doesn't, you know that that last recorded number, volume, was the correct one. All right, so I'm just gonna add a little bit. I don't think in your books it does say it goes from yellow to red, but that's pretty much like litmus paper. You know how the colors are a little bit funky. Whoops, that was a lot that time. Okay, so I feel that's where we hit it because it's not changing color now. Okay, so we've reached the end point. So that's what they call the red, if you will. Okay, so again, it started off, let me see if I can focus on this one a little bit. There we go. So it started off in that green color. So that's sodium carbonate and methyl orange. And I added HCl just to bring it to the yellow. And then I slowed things down a bit, gradually adding HCl until it started to turn color. And then when that red color stayed, I knew I had hit the end point. So again, I will do that 3 times with sodium carbonate in the Erlenmeyer and HCl in the top, in the burette, the titrant. And then I will go to my notes and I will show you how I do the calculations. And by doing the calculations, we will be able to determine the exact concentration of the HCl in the burette. Then we will instead put ammonia in the bottom, and we will titrate it 3 times with ammonia in the bottom, adding HCl each time until it turns color, and we will be able to figure out how much ammonia was in our samples. And usually chemists will do at least 3 trials, and the values have to be relatively close to one another. If they're not, we consider outliers, and we only use the data that's relatively close, and I'll explain that when I go back to your notes. Okay? So this is trial 2. I just thought it would be fun if you saw how I added the HCl, and it's gradually going to go from this not so pretty green color to yellow. I'll speed up the drops a little bit. Okay, and again, we're using an Erlenmeyer because if I were trying to swirl this in a beaker, I'd risk splashing it and getting drops everywhere, and that again would affect our concentration. Okay, that's a pretty steady flow of titrant. Now you can see how it's turned yellow. So now I will slow it down yet again. Because as it's hitting, it's turning pink. Okay, so if I move my thumb for a second, there you go. You can see how it's dropwise. The longer the pink color stays, the closer you know you are to the end point. Okay, so it's staying a little bit longer, so I closed the stopcock. Okay, can't really see that, I realize, so I have it closed. And I'm going to record the volume now because I know I'm getting close. Opening the stopcock. Okay, so that's probably the volume. So again, I would get out my meniscus reader and I would record the volume as best as I can with the meniscus reader. Okay, so grade 12, that's the end of my titrations. I will show you the calculations and I will show you all the numerical data for the 2 sets of 3 trials. That's all I'm going to do visually with the burette. I just wanted you to see the setup and see how I made the solutions. So again, there is my complete burette setup, complete with the candle I was using to try and hold my camera. Okay, so there's your burette, your Erlenmeyer, your burette clamp, the stopcock on the burette, okay, the white base. All right, and then again, you can see my graduated pipette that I use, my volumetric flask, my pipette pump. There we go. Alrighty, so I think that concludes the experimental videos, and then I will, as I said, put all of this together with sample data, and you can see how we indeed determined the calculations or the concentration of the ammonia. So I just want to refresh and summarize grade 12. We used a sodium carbonate solution to determine the concentration of hydrochloric acid that we made. And you're saying, why did we do that? This is a primary standard. This is primary standard, which means assuming I follow proper lab procedures and make that as precisely as possible, then I can determine its concentration just by calculation. It's a primary standard. It has a large molar mass, it doesn't react with very many things, and it does not absorb water from the air. I find its concentration using calculations, and then I titrate it with HCl. The indicator I use is methyl orange because I know that it will turn color when those two neutralize one another. Strong acid, weak base, we're going to use methyl orange, okay? Because the pH will be closer to the acidic end, and this one has a pH range closer to the acidic end because it's a strong acid, okay? That titration allows us to determine the exact concentration of HCl. I use the HCl and I do 3 more titrations, but this time I'm titrating with the HCl in the burette and a sample of ammonia in the Erlenmeyer. And I do the exact same thing 3 times, and that allows me to determine the concentration of the ammonia. There's an example of what an air bubble looks like. And I can't get rid of it right now because the burette is empty. But ordinarily you could tap it like I'm doing and get rid of that air bubble, but because the burette is empty, I can't. But I wanted you to see what an air bubble looked like, okay? So ordinarily, this would be clear all the way down. You wouldn't see this stop, okay? So that's evidence of an air bubble, and you would have to add more of your titrant, let it drain a little bit to get rid of that air bubble, and then measure your initial volume again, okay? Or rather than having it drain, just tap on it like I'm trying to show you, not so clearly here. Okay, I'm just flicking my fingers like this, okay, to get rid of it. But regardless, you'd have to measure your initial volume again.